Yes, good afternoon, ladies and gentlemen, my colleagues, the youngsters of KYU. How are you guys doing? Long time, I know. Last week I wasn't in. I went to somewhere to our neighboring country looking for bridges. I looked at about 3 different steel truss bridges. And after that, I decided that I should come back and share with you. And I remember I shared even when I was there some few photographs so that you could appreciate that. Today I want to talk about steel truss bridge. Bit of design, bit of construction, a bit of maintenance, and then also we'll look at a bit of one model using Midas. I think as you can see on the screen here, we have a typical, I think this is about 80-meter span of steel truss bridge. This is the Warren type without vertical members. Both have got, whether with vertical or not vertical, they both have some advantages. So, and this is the U-type abutment. I considered rock foundation, rock strata at the surface is wide enough. So basically, this is what we may talk about. So, but briefly, what do we know about the steel truss bridge? So, design, construction, and maintenance of steel truss bridges. A brief narrative, and then modeling using Midas. This is engineer MJ Ochola, Michael Jackson. I'm a certified project management professional from USA. In addition to my knowledge in bridges and structures, I also manage project implementation and also preparation. Yeah, so go straight to steel truss bridges. Basically, before you jump to what steel truss bridges, we do have quite a number of bridges. We have concrete bridges, concrete bridges. Under concrete bridges, you have a reinforced concrete, you have a post-tension, pre-stressed concrete. Under pre-stressed concrete, you go into post-tensioning and then pre-tensioning. And then reinforced concrete, you also have an element of precast, whereby you cast the concrete at the yard and then you just lift and place up. Then we have steel truss bridges. This one comprises quite a number. We have the arch bridge, we have the normal, this type here, which we have talked about. You're going to see the different types. So steel truss bridges, actually, they're applicable for spans between 55 to 100. So if I go straight to what I've jotted down, not to waste much of your time, I think steel truss bridges are a type of truss bridge where the primary structural elements are made of steel. Basically, it is steel of different grade, of course. Of different grades. You have grade 235, you have grade of 275, and you have of 355, and so on and so forth. Depending on the level of ductility you require, and then the region, because bridges are specific to regions, you are able to adopt. Where you have earthquake effect, you also need to go for what is more ductile. So these bridges are known, steel bridges are known for their strength. They're actually stronger than concrete. If you can make collection well, reinforcement bars, which is a part of steel, we use it to reinforce concrete, which is good in compression. So they are very good. They are known for their strength. They are known for their durability if well protected. If you expose steel to corrosive nature, harsh environment, if you expose steel to fire, definitely you saw what happened to World Trade Center when it caught fire. You definitely know very many things can happen. Once the temperature is elevated, the strength and the durability definitely reduces drastically. And then also their efficiency and efficiency in using material. Whatever you specify the quantities, normally you utilize them to the fullest. And then the waste normally it doesn't exceed 5%, like for concrete, where for cement you go for almost 33%, sand almost 20, because the uncertainty is too much. But for structural steel, because of the nature of production, you don't waste much of that. The steel truss bridges are known for spanning long distances between 55 and 100. Here are some key points about steel truss bridges. This is a typical truss internet source. We have the top chord, we have the sway braces, we have the top lateral bracing, you have the floor beams, you have portal strut bracing, bottom chord. So basically you have all these elements. And so basically these are things that actually, but they're quite a number. Once the structural steel is fabricated and assembled, then you can put your deck. The deck can be steel or timber or concrete, whichever choice you make. So steel truss bridges consist of a framework of steel beams arranged in triangular units. This design helps distribute loads evenly, mainly making the bridge capable of supporting heavy weight over long spans. They behave like a closed box structure when it has 4 planes capable of resisting shear and end portal sufficient to transmit shear back into the vertical loads at the bearing. So the configuration itself generates a very good, easy to follow load path, which you can guide direct up to the end span where you have bearings that transmit this load onto the substructure system. They are characterized by bracings and wind carrying members, in addition to those members seen in front elevation. Definitely, most of these bridges are faced with simultaneous loading. You have the dead weight, you have other superimposed dead load, you have traffic load, you have the effect of wind, you have earthquake, you have water. So in a way, the configuration has to be in such a way that it can also take up what they call torsional effect. So you need to enhance the torsional rigidity using those closed like loop or frames that are aligned to make what they've talked about, closed box structure type kind of. So there's a lot of science when you are dealing with steel truss bridges, but they're very, 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 very easy to follow. And once you understand the art, you should be able to do that. Bracings of steel truss bridges act as alternative load path in case of uncertain failures of main members. Definitely, if you have your bottom chord, you have your top chord, you have your strut ties or vertical and diagonal members, and in case of any eventualities and one or two fails, so the other bracing tend to help in distributing the load. Today, in the era ANA World Road Association, the technical team ANA Bridges they have started advocating for resiliency of bridge structures in all weather. Bridges must be adaptable to climate change. We also need redundancy. Members, we need to have extra members like these trusses. If you have strut ties, you need extra strut ties to take the extra load, or in case of one or two getting damaged, then the load path will not be distorted. And also for retrofitting, so it is very important that we begin to move slowly into the new era that is being advocated by the experts across the globe. And they're looking at resilience, they're looking at redundant members that need to be, but in brief, this conservative design is now important, because you have seen what happened to Baltimore Bridge. They had on a 2 support system, and and then the bearings were on that, and then the extras. So if you have like 2-3 piers with continuous truss system, definitely you are able not to have that disastrous collapse like a glass falling onto rock. That doesn't work. So also coming up with high-grade materials is very important, and also extra substructure system like more peer support is very important. So this is now what is being advocated for. The different types of steel bridges here, we have the Warren type, we have the Hoare type, the here A, B, C is the Pratt type, D is the Baltimore, and then E is the Parker Truss. But there are more. This Parker Truss is like camelback. So these are some of the few that I managed to pick, but I know you guys with time should be able to get more and more and more, because you are in the field. The students are also reading more, so I think there are quite a number. The Warren type of truss system are the equilateral triangles, and this style they use both vertical and diagonal members in load carrying capacity. Hoare type, the diagonals face away from the bridge center. The vertical members are always in tension, and the diagonal members are in compression. While the Pratt type, diagonals are vertically parallel and slope towards the center. Vertical members are in compression and diagonal in. So members, I think normally when you are picking some of this type, don't swap and don't change the orientation the way they have done, because these are predetermined structural configuration with time. If you change, then you need to design. You may find some distortion in your load path, or even the some members will be failing, and then you find that the structure system may not perform well. So sometimes it's important to adopt what has already been done, and then you do a bit of research to see how you can adjust that. These all I got from the internet source. The advantages of steel truss bridges are highly efficient in material usage, which makes them economical to construct. They are also very strong and can accommodate dynamic loads, making them suitable for both road and rail traffic. Definitely, with post-COVID, prices of steel went up, but now it's going down. So that is now at least the wiring trend is coming down, and I think we should be able to continue with use of structural steel where it's necessary, especially the plate girders and then the truss bridges, like I saw in the neighboring countries recently, where they are basically doing a lot of truss bridges. The history of steel truss bridges in the world, I think this table has it all here. You have the Quebec, the Minato Bridge. These were all from 1917 to 1966, but the trend continues. So these bridges are commonly used in a variety of settings, including highways, railways, pedestrian pathways. They are particularly useful in rural areas where long spans are needed to cross rivers or valleys. Since 1917, the industry has experienced use of steel bridges as highlighted here. So you can see, I think the dominants are Japan and USA, with at least India coming in, and also Canada. The design principle of truss bridges are to distribute load through their triangular units. The members of the truss are typically in tension or compression, which makes the structure very efficient. Selected iconic steel bridges around the world. I made mention of, I think, Minato in Japan. Then we have, that's about in this span here, the main inner span is about 510. You have the Quebec in Canada is about 549, the inner, and you can see the kind of configuration. The good thing with steel, you can do configuration the way you can look at Tokyo Gate Bridge, how it is configured and the span. So, and then you also have Commodore Barry Bridge in the USA. So this information I got from Oriental Consultant Global when we were doing our training in long span bridges in 2017. Design of steel truss bridges. Here there are few points. I think the point number one, I think it is to determine the design parameter. I think you know very well what needs to be done when you're doing design. You look at the span length, you look at the bridge width, you look at the load capacity, the materials, you look at the vehicle. Then you select the truss type, whether it is the Pratt type, the Warren type, the Hoare truss. The other types are K truss, Parker truss. Then you also calculate the truss geometry. You need to know the top and bottom cut length, vertical. Now, once hydrology has given you all that, and you know now the span fixed, then you start playing with the configuration to limit deflection, excessive deflection, and also to avoid heavyweight material to go there. The closer the configuration, the lighter material to the mobility of material to mobilize. So you have to be mindful when you are doing some of the things. Then you determine the member sizes, top and bottom cover, on a preliminary concept, and then you analyze the truss system, and then from there, number 6, you design the connection. Very important to note is steel bridges have a lot of connections, and that means they are subject to high fatigue failure rate, because you have bolt connection, you have weld connection, you have plate connection, and these are high, what they call stress risers. These are stress concentration, where we have high stress concentration, we call them stress risers. So with time, with cyclic loading, you find if you have any crack initiation, the bolt plate connection or weld plate connection, then every time any load is exerted on the bridge, this crack continue to propagate from initiation. It propagate up to a certain point, and then you just see a sudden collapse. So it is very, very highly that you need very close monitoring to ensure that you can identify cracked initiation in connections of steel bridges to avoid premature failure from cyclic fatigue loading. And so this is a brief general outline of design procedure. Then there is also an element of construction of a single span steel bridge. Here the procedure is very simple. These are what is in the factory. Cutting and fabrication normally is done in the factory, and then you only do side bolting and the rest of it. You cannot do for hole making, welding, which are X-ray control. So you have cutting, marking, you have cutting, you drilling holes, you have to fit up and tack, weld it. Then you do welding when it is in the final position. Then you do inspection and try assembly. You do painting, transport, and assembly your bridge. This is how simple bridges can be done. If you have two cranes and the rest, you should be able to launch your truss girder, and then you do assembly from up. Mostly basically bolting. The rest of fabrication is done from the factory. Then you can see the process here. There's actually 1 up to 7. Basically setting out, excavation, abutment, construction. A lot of control, quality control is important here. Precision is important. Bolt location need to be maintained. Then other construction technique are continuous construction, like the Minato. You can see what happened. You have to cater for design changes to avoid collapse. Normally, if changes are made, you really need to go back on the drawing board and check, because during construction many things can happen. You also have to cater for adequate jacks for temporary support and bearing to avoid collapse. Sometimes the jacks are inadequate, and remember, the centerpiece like this can outweigh the capacity of the jack. And it's like Quebec Bridge collapsed in 1907 due to design changes. They changed, but they underlooked. They went ahead. It collapsed again after nine years. Due to less jack capacity, it also collapsed. So normally we have to be very, very mindful when we are doing that. So these are some of the bridges that which have experienced a bit of collapse during implementation or after implementation. The steel truss bridges have experienced several notable collapses worldwide, often due to structural failure, design flaws, or external factors. Here are few. We have Seongsu Bridge in South Korea, 1994. The I-35W Bridge, USA, 2007. You have the Kauras Bridge in India, 2012. Francis Scott Key Bridge in USA. So that is, you can see, this was the you can see this bridge here. This is Seongsu. This is before collapse, and this is after collapse. So you can see, and now there were deaths registered. So these are things we need to be careful with. This is the internet source. Durability of steel bridges. Definitely the longevity of any bridge require a bit of attention. Bridges are like human beings. I grew up, I was a young guy, strong. Now you find there are certain weight that I could carry. Now I started reducing the weight. Again, now you see they say, don't take sugar, don't take salty stuff, because you're trying to reduce chemical substance into your body, which tomorrow can affect you. The same thing happens to the bridge. A bridge exposed to harsh environment will deteriorate slowly but sure. If you design a bridge for 120 years, and you subject it to very harsh environment, contaminants, chemical, acidity level, then it may get corrosion, and member sizes will be distorted, cross section will be distorted, which are functions of performance and capacity, and definitely you can see that with the ever increasing load, you see your bridge collapsing before it reaches 150 or 200 years. So lifespan of a bridge is at least 100. Durability depends on timely inspection and intervention. One of the many factors that affect the durability of bridges is fatigue. This is now when you talk about steel, whether it is steel plate girder, bridge, or steel truss, where you have connections. Because trusses have a lot of connections, therefore they are subject to high fatigue rate for failure. How does fatigue occur in steel bridges? Fatigue failure in steel bridges occur due to repeated application of stress. It causes small cracks to grow over time, which propagates with time and lead to fracture. This process is typically driven by cyclic loading, such as the constant passage of vehicle over time. Key factors contributing to fatigue failure include stress concentration, materials defect, environmental condition. I already explained that. And stress concentration, areas with abrupt changes in geometry or where different materials meet can have high stress concentration, making them more susceptible to crack initiation. I told you where you have the bolt and the plate, where you have the welding two members, and especially if you are dealing with plate girders and you have welded near high stress area concentration, definitely you're going to face that problem. Environmental condition goes to corrosion and corrosion factors. I've told you there are many. Then the areas prone to fatigue are girder web and flange, both balls and wells, connection plate, and the rest. Preventive measures are basically regular inspection, maintenance to address corrosion, and designing bridges with fatigue resistant detail. Protection of steel members for desired longevity. This is now about painting. I got this information, but also from Oriental. A very good narrative. I think with time, please have a look at the coating, corrosion protection methods. You have with the coating, you have non-metallic coating, you do painting, and you see how painting is done down here. Almost 5 different layers. And then you have metallic coating. This is where we do galvanizing with thermal spray, and it gives you the longevity, and the bridge will perform as it is designed. Then the materials, even a bridge, you can get a weathering steel or stainless steel where you don't apply. The material itself will resist a bit of that corrosion. So painting in rural areas, if you do the service life of painting, is about 60 years. Then urban area 45. Ocean area, you know, because of that chloride and other things, a lot of chemical and other things, the environment is a bit harsh. That's why if you have a steel structure facing the sea, the side facing the sea, you'll find it corroding before the one facing the other side. So you have to take note. All this time you can see that the one which are in the ocean area have fewer years in service than the one in the rural areas farther from the sea. So now painting steps do you need to take the painting? There's this fluorocarbon, polymer coating, and other things. You can see they have about this is the steel, but you have primer 1, you have primer 2 and 3, you have, so these are steps that normally it is taken from the factory. If you get a steel material for your bridge and it is not done, and they want to apply this ordinary paint from the site, ladies and gentlemen, you must know you have failed test number 1 on durability control. Painting ordinary paint, it lasts around 3 to 5 years. So you need factory control painting with better processes and procedures which are checked and approved at every stage. So basically that one of the references that I looked at is the Bridge Engineering Handbook, edited by Y. Fasan, Lian Duan, and internet articles and text references. I know we have a lot of text which we can read about steel, truss bridges, and the rest. Please have time, get time, read. I may have just introduced the topic, but you can do better. Look at them, appreciate. There are quite a number related to what the theory of structures, what you learned from the undergraduate and after masters. So try to look at it. Steel truss bridges still work very well, and they are durable, maintenance free. All we need is to take care and look after them. That is what we need to do. So that is something that I thought I should let you know. But you also need to protect them from fire. Very, very important. Fire is important to keep away from steel bridges. And also overloading. You have to have your axial load control system properly done to avoid overloading the bridge, which will initiate craft propagation, and then there in few years you see the bridges giving way. So I think this is my brief narrative on design, construction, and maintenance of steel bridges. Thank you so much. Have a lovely time.